Hello class, today we will be doing a lesson on hypothesis testing. So to start off, we have the null hypothesis, which is listed as H0, and this is assumed true until proven false. Then we have the alternate hypothesis, which is listed as H1, which is what is depicted as true if the null hypothesis is false or rejected. Okay, and then we have the two-tailed test. In order to determine a two-tailed test, the null hypothesis must be equal to a certain value if the alternative hypothesis is not equal to it. So whenever you have an equal to and a not equal to sign in the problem, that's when you can identify it by using the two-tailed test. Okay, and now we have the one-tailed test. We have a left and a right. So in order to determine if you have a left, to use the left one-tailed test, the null hypothesis must be at least a certain value where the alternative hypothesis is less than the value. So when you have a less than sign, that's when you want to use the left one-tailed test. That's when you can determine that. And you can determine another one-tailed test, but the right side is when the null hypothesis can't be more than the value, but the alternative hypothesis says it must be higher or greater. So whenever you have the greater than sign, you can determine a right one-tailed test when you have the greater than sign. Now we're going to talk about the type 1 error. A type 1 error is when you reject the null hypothesis when it is actually true. So for example, we have the null hypothesis here and it states the earth is not at the center of the universe. Okay, so in order to test this, say you sit outside and you watch everything in the sky is revolving, the stars and everything, so therefore this is not true, so you want to reject this null hypothesis, clearly stating that the alternative hypothesis, which is the earth is at the center of the universe, is true. So the alternative hypothesis will be true. Okay, and now I have an example here to show you how to determine and find the p-value, the test statistic, the critical value, and the conclusion. Okay, so my example says, an article in a journal reports that 34% of American fathers take no responsibility for child care. A researcher claims that the figure is higher for fathers in the town of Littleton. A random sample of 234 fathers from Littleton yielded 97 who did not help with child care. Test the researcher's claim at the 5% significance level. So my null hypothesis I have here is P is less than or equal to 0.34. And then the alternative hypothesis is P is greater than 0.34. So this, you can determine that it's a right-tailed test. Okay, and then so I'm just identifying my values here. So for Q, I have 1 minus 0.34, which we got 0.34 from the 34%, and that equals 0.66. And then we have N, which equals the sample, which is 234, which we got from the sample. And then we have P equals 0.34, which is the probability of the 34%. X equals 97, which we got from the yielded 97. And then we have the P hat value, which is the X divided by the N, which we get 0.415. Okay, and then our significance level is 0.05 because we take this 5% and move it over 2 places. So in order to find the test statistic, we use this formula. So I'm going to show you how to find this. So we just plug in the values. Z equals P hat, which is 0.415 minus P, which is 0.34. And we take all of this and divide it by the square root. The square root of 0.34 times our Q, which in this case our Q is 0.66. And we divide that by N, which is 234. All of that is square root on the bottom. So then we come to find out that our z-score equals what we enter in to our calculator that we can use here. Okay, so first we want to do 0.14 minus 0.415. 0.34, and that will equal 0.075, and then we can divide that by the square root of 0.34 times 0.66 divided by 234, and then we will get 2.4219, but we're just gonna write that in here, 2.42. Okay, and that is our z-score that we got, and that's also our critical value. Okay, so now you see that we determined the test statistic and got the value z equals 2.42. Okay, so now we are moving on to find the p-value. Oh, also on the curve here, the right one tested curve, the critical value is 2.42 here as well. Okay, and then when you put this into the z-table, we get 0.992, and this is how we're going to find the p-value, because we subtract 0.992 from 1, and we're going to use our calculator. Let's clear that, and then we're going to get 1 minus 0.992, and that will equal 0.0078. So 0.0, what was that again? 0.78. Okay? So now we can do our conclusion about the null hypothesis. After we did our test statistic and found the z value, which is the critical value. We found the p-value by subtracting the 0.992 from the 1, and we got this as our p-value, so that's how we found the p-value. And now that we have all of our data to conclude about the null hypothesis, we can see that we must reject the null hypothesis because 0.0078 is less than our significance level of 0.05. Okay, now that we found all our values, we can conclude about the null hypothesis, which we must reject the null hypothesis HO because the p-value 0.0078 is less than our significant level of 0.05. So when it's less than, we must reject the null hypothesis. And then our final conclusion is there is not enough evidence to support the claim that the figure is higher than 34%. Okay, so in this example, we can see I use the null hypothesis, the alternate hypothesis you can see here, and this is the right tail test because it depicts a greater than. Okay, and then we did the test statistic with using this formula, and then after using the formula and plugging in all the values, we get the z-score, which is the critical value of 2.42, and after we put 2.42 into the z-table, that's when we come with the 0.9922, which we subtract from 1 in order to find the p-value here in this problem, which we get 0.0078. And then after we find those values, we can now make our conclusion about the null hypothesis and the claim in the problem, which we must reject because the p-value is less than our significant level.